I'm based in Hobart, Tasmania, which is the southern state of Australia. For those that don't know, it's an island state, and Hobart is considered the gateway to Antarctica for Australia and a lot of other countries. A lot of the other nations come through here, and just last week we had the German icebreaker docked here in Hobart, and we had the Japanese research vessel here too. So it's a really great place for Southern Ocean and Antarctic research. If anything funny happens with my screen, please do let me know. So the Continuous Plankton Recorder program was started by this person here. This is Sir Alistair Hardy. So he started the program in the 1930s. Basically, he was looking at the larval fish stocks in the North Atlantic, and he wanted a way to monitor how these fish stocks were going. And there currently at the time, there was nothing to do so. So he invented this program himself. I'll talk a little bit later about the mechanics of how the plankton recorder works, but basically it's the love child of this person here. Since the 1930s, so in the last almost 100 years, the Continuous Plankton Recorder has had many different projects across the world. And this image here shows all the different projects that are currently being run by different states. So up here in the red, we can see the program invented by Sir Alistair Hardy. This is in the North Atlantic. You see a couple of programs from North America across the Pacific, Africa and South America run a couple of programs. And then over here in the corner in the pink and the green, we have two programs run out of Australia. So as you can see, the Southern Ocean and the areas around the Arctic, the Northern Pacific and Atlantic are fairly well sampled. We have huge gaps across the equator. We have huge gaps in other sectors of the Southern Ocean. And I suppose the reason that this is it's quite expensive to sample in these areas. You know, there's not a lot of land over here. So for research vessels or any vessels to head out into this part of the ocean, they need a real reason. So it's not often sampled. For Australia, we have two programs that we currently use through CPR. So we have the Australian CPR program and the Southern Ocean CPR program. So both these are possible through collaboration between a few different organizations. We have IMOS, which you can see the little image of here. That's the Integrated Marine Observing System. The Australian Antarctic Division, which is through the Department of Climate Change, Energy and the Environment and Water. That's Australia's Antarctic program. IMAS, which is the organization that I work for, Institute of Marine Antarctic Studies, and CSIRO. CSIRO is Australia's sort of national research body. They look at everything from ocean science to cancer to developing food. They do everything. So any tow that happens on the Continuous Plankton Recorder north of 47 degrees south, these are processed by CSIRO and they fall under the AusCPR program. Any tows that are done south of this 47-degree line, they're processed by the Australian Antarctic Division, and they process the zooplankton side of things. And then IMAS/IMOS, who I work for, they process the phytoplankton, and this is the Southern Ocean CPR program. So two different programs that work fairly well together. I collaborate with CSIRO and work on the AusCPR program as well. Zooplankton processing dates back to 1992. So it's 30 odd years, 32 years, and it's been continuous throughout to now. And then a bit more recently, in the last sort of 15 to 17 years, phytoplankton sampling has also happened. So not as much data for the phytoplankton, but since its inception, it has been continuous until through now. A couple of bumps during COVID, as can be expected with shipping, but otherwise continuous. This is just a quick little map I made showing the sampling effort of the CPR program over time. We have the years counting up in the top left, and a green dot shows where the CPR has sampled. You can see when this rolls over again and starts at the start. In 1992, when it first started, there's only a couple of little dots that sampled as they were trying out the system. And it's not until sort of the 2000s that you get a real explosion of sampling. The important thing to note is that the CPR, which I'll go into detail on in a sec, gets towed behind any vessel that can take it. So there's a sub-facility called the Ships of Opportunity under IMOS who run the CPR programs, and they will put one of these machines behind research vessels that head to the Antarctic stations, merchant ferries, cargo ships, mining and gas exploration ships. So any vessel that's happy to tow one of these CPRs, they'll throw it on the back of and get data for, because it's a very passive instrument and it allows for a broader sampling area. We'll also note that this is Hobart here on the map, if you can see my mouse. So the majority of sampling happens as vehicles travel from Hobart to our Antarctic stations. We have 3 of them on the continent. And also there's a port or a harbour town called Fremantle in the west, where sometimes vessels will travel out of Fremantle too. So a lot of these lines, a lot of the sampling happens as a result of these shipping routes. The vessels are traveling to Antarctica to resupply stations with food and personnel and diesel and things like that. So just as a result of that, that's where you're going to get most of your samples. As I said, it's a passive instrument, so you can do that. This is what the machine looks like itself. It's a torpedo-shaped machine, probably about 1 meter in length, and it weighs a ton. This thing is heavy. So basically, it's towed behind these vessels, as I mentioned, at about 10 meters deep. And at this depth, it flows behind the boat and water flows through the entrance aperture here and out through the exit aperture. As the water's flowing through this machine, you have 2 bits of silk here. You have a covering silk and a filtering silk, and these are both on a spool, and they are slowly rotating, and they come together like a sandwich, and any of the plankton that is in the water at the time gets sandwiched on this silk. As it goes, it has a propeller and a flow meter, and eventually the 2 bits of silk get stored in this storage tank, which is filled with formalin, which preserves the zooplankton and the phytoplankton that are being captured on the silk. So this is happening while it's being towed. Information about the underway data from the ship is happening. So GPS, latitude, longitude, things like sea surface temperature, salinity, fluorescence. These are all being recorded at the same time while this is being towed, and you can correlate them back to the position of the plankton of the CPR. So in a tow, an average tow, this machine will be towed sort of 400 to 500 nautical miles. And in that space, we'll be able to determine where on the piece of silk the plankton was taken using the propeller, using the flow meter, and using the onboard GPS. So this machine is, I mean, there's been some small tweaks, but since the 1930s, not much has changed. It's all mechanical. If something's broken, you can fix it. So it's a really good, really solid design. This is what it looks like on the vessels. So you chuck it on one of these A-frames and deploy and retrieve pretty easily. You can see that torpedo shape. And in this image here, at the bottom of this image, you can see the internal cartridge. So right here is a piece of silk, and there's another silk inside there, and that's what rolls up into to capture the plankton. So you only need a couple of people to sort of put the cartridge in, unload, reload, and put in the water. It takes all up, I don't know, maybe 10, 15, 20 minutes to get it ready for deployment. And then back in the lab, these are 2 colleagues of mine, Rob King and Dr. Olivia Johnson. You can see the 2 bits of silk coming here together from the internal cartridge. And this cartridge will have a wealth of knowledge on it, lots of plankton on that cartridge. This is a video provided by our previous chief scientist at the Australian Antarctic Division on our new research vessel. The Australian government commissioned a new icebreaker, which has started running voyages in the last 2 years. Very exciting. So I suppose the key thing I'm trying to point out here is that the CPR machine is a very easy passive instrument. As you can see from the video, you can put it in the water while the ship's still moving, and you can retrieve it while the ship's still moving. Apart from the loading and unloading, it's very resource light. It doesn't need too much work. Just a couple of people putting it on the winch and putting it in the water. I guess the most laborious part comes in the post-processing, which is where my job comes in. The first thing we do when the silks come back to us, so they come off the boat and they get sent to myself and my colleague John at the Australian Antarctic Division. And the first thing we do is we roll out this long piece of silk, probably 5 or 6 meters long, and we do a very basic visual analysis on the phytoplankton color index. So we have like a swathe of colors, and we roll out the silk and have a look at how it looks physically. So this is what known as PCI1, or phytoplankton color index 1. You can get as low as 0, but basically this is telling us that there's actually not much happening on this silk in terms of possibly phytoplankton and zooplankton. You can see a couple of dots of color here, a couple of pink splodges. There's maybe an animal up here with the black section. But just as a very initial analysis, a visual look at this tells me that there wasn't much happening in the ocean at the time. And then, for example, against the difference you can get, we have a sample here that's got a PCI of 2 and a PCI of 3. So 3 is the maximum you can get for this very basic analysis. You can see instantly the difference in color. So the green would be all the chlorophyll from the phytoplankton blooms. And then all these dots, they're these bumpy bits, potential zooplankton. We get a lot of krill down in the Southern Ocean, especially if you just get close to the Antarctic continent, get a lot of Antarctic krill. And as we all know, they have one of the highest biomasses of any planet animal on the Earth. So when you go through a swarm, you really go through a swarm. Obviously, the organisms in here do get a little bit smushed, so that makes the job of my co-worker John a little bit hard at times. The next thing we do is we cut up the pieces of silk. So because we've got that underway data from the vessel, and we know how far the tow has been silked, we do a little how far the silk has been towed rather. We do a little bit of quick maths to work out how far or how long each piece of silk would be if it represented 5 nautical miles. So we roll out the silk, do our measurements, and cut the silk into representations of 5 nautical miles, which end up being probably 7 to 8 centimeters per segment. So I'll take a segment, put it under the microscope, and start counting. So the way that I count is if you imagine this rectangular piece of silk and imagine an X cutting across the silk, starting in the top left, going to the bottom right, and then from the top right to the bottom left. Within that X, I count 20 different fields of vision down the microscope lens. So if I see, or what's something I see a lot? If I see something called Thalassiothrix antarctica, which I do see a lot down there, if I see it in one field of vision, in post-processing, that'll be extrapolated to an abundance. If I see it in 15 out of the 20 fields of vision, that gets extrapolated to a larger number. So this method is standard throughout the world that uses continuous plankton recorders. And it's basically presence abundance per field of vision. And the more times you see something, the larger the bloom was and the larger the number ends up being. So once I'm done with the sample with the phytoplankton, I then pass it on to my colleague, John Kitchener. Per tow, per 400 nautical miles, you get around 80 or so segments. And so once I've done a full tow, when it's done 80 segments, I pass it to my colleague, John. This is John here. This is Kunio Takahashi from NIPR in Japan. And John will wash the silk to get all the zooplankton off of the silk. So it's imperative that I start the process. Otherwise, I can't go back to me after John's processed it. So he'll wash the silk, get the zooplankton off, and then he'll take a subsample, count the zooplankton, and extrapolate from there. Thought I'd show you an image of what it looks like down the microscope for myself. So these brown sort of meshy looking material, that's actually the thread of the silk. And what I do is I count the space between the threads. This blue space here, this is one field of vision, as I talked about before. We can see this beautiful corythron poking its head through. These are one of my favorite diatoms for those that don't know this one. It's eccentric. It's just like a cylinder with a little cap. And it's got these beautiful long setae. They have spikes on them and little hooks on them. And the hooks are diagnostic. Obviously with this one, the hooks have been torn off, but I just thought a cute little picture of it poking its head around the corner. So the data output, I thought I'd show you, if I skip over to here, this is where the data is stored for these programs from Australia. So this is called the AODN, Australian Ocean Data Network, and this is publicly available, free for anyone to jump on. It's got the website here, and if suitable, I can share the website with everybody. But basically, any product that IMOS runs, their data goes through here. So it's simple as going to the search function at the bottom, type CPR, hoping my internet is strong enough. Yep. And then we have 3 different options for CPR here. So we have phytoplankton abundance and biovolume, zooplankton abundance and biomass, and then Southern Ocean zooplankton. So this middle one is kind of a collaboration between.
Sorry, Luke, this is Sarah. We're not seeing that yet. At least I'm
Oh, I'm
not.
sorry, hang on.
Maybe it's just a little slow on the advance. I'm seeing data output slash.
How's that?
Okay, there it goes. Open access to ocean data. Now I see
Thank
that.
you, Sarah. Thank
Sure.
you. So all I've done here is I've typed CPR in the search function at the bottom left here, and it's popped up with 3 different options. So we have the phytoplankton, zooplankton, and then together. So it's as simple as selecting phytoplankton abundance. Again, some patience with my phone internet. And here we are, you have a map of Australia, and every yellow point is a data point that's been sampled by the Continuous Plankton Recorder program. So you can choose your bounding box, choose this part of the Southern Ocean. You can put a temporal range in. So if you just want samples taken in 2017 to 2019, you can put that right in here. And then once you've selected your time and your space, you click next, and it allows you to download the data set. It is really easy, open source data for anyone to use. So I'll just talk about what you can do with this sort of data and what it looks like. So I'll go back to sharing my Alrighty. So when you download that data set, if you did the zooplankton, this is what you get. Some things are superfluous, but some are very important. You get the segment number, the species name. So this is Antarctic krill here, Euphorgia superba. The ship codes. This is our old vessel, the Aurora Australis. The year that it was sampled, and then you get a lat, a long. And if anything was recorded underway, you also get that. So you get fluorescence, salinity, temperature, and the abundance found for that species in that spot at that time. For the phytoplankton, similar. You get trip code, sample ID, region, etc. Latitude, longitude, obviously very important. You get the year, month, day, time, sea surface temperature. It's good to note that not always is these data taken. So chlorophyll A wasn't taken consistently across this voyage. And then across here we have the species. So basically every species that's ever been seen on the Continuous Plankton Recorder program for Australia will show up on every Excel document that you download. You just get a lot of zeros in the data set, and that's fine. I'll show you what I thought would be good for analysis from this. So an important thing that you can do is, now that you've got the data for phytoplankton or for zooplankton in the area, you'd start to produce maps on the total abundance of these things, and you can split them by year. So this is a pretty easy map I made using R with the data set, just as you saw it downloaded straight from the AODN. And I've split all phytoplankton abundance by the year. So instantly you can see some differences in the sampling effort. What I haven't shown here is a sampling effort when you get a 0. For example, if let's say in 2007, if the ship sampled here but didn't find anything, that won't be shown on this particular map. This is only when there's presence of phytoplankton. So you can see, a marked difference between sampling across the years. 2010 was a good year for sampling. 2011 and on, you can see, the end of 2019, 2020, COVID affected things, obviously. There was an upward trajectory in sampling until 2020, but came back strong in 2021. And 2022 was again a lean year, but we're just still processing the data from these years. So I've just split this by year, but you can split it by species. So if you look in the data set and you can see a particular species is of importance or of kind of interest to you, maybe, for example, Pseudonychia, it's a species that can produce toxins. So if you're trying to see how Pseudonychia has done across the years, you can interrogate the data set and map just Pseudonychia, and you can see how it changed from 2007 to 2023. You can track it with marine heat waves. You can track it with the moving of the East Australian current, which is really interesting. So we have this current down the eastern side of the country called East Australian Current. If anyone's seen Finding Nemo, it's what the turtles ride on. And this has been moving further south each year. So in Tasmania, where I am, we've gotten bioluminescent plankton showing up in the water that haven't been there, that weren't there 15 years ago, which is an incredible spectacle to go down and see the water flashing blue, but ecologically it's a worry. And we actually had a sea turtle come into Hobart this year, which is exceptionally worrying. Being the gateway to Antarctica, seeing a sea turtle at 42 degrees south is a little bit worrying. But you can track these things. You can track the plankton changes in plankton across the years and correlate them to these ecological values. And I thought another cool map that could show that the power of this program. I'll just change my share again. All right, is that showing a map? Can everyone see that?
It is. Yeah, we see that.
Thanks, Sarah. So this is a map or a package called MapView in R. Very powerful package for those that aren't aware. You can change your base map pretty quickly, pretty easily. And there's, 100 or so base maps. And the cool thing about this is you can click in your data set. So in the other data set, we could see that, I might just switch back to it. So here we can see that, 2010 and 2011 had similar sampling areas here in the Southern Ocean. And so did 2021. But you can see quite a big difference in the phytoplankton abundance in 2021 versus 2010 and 2011. So we can go back to our map. And we can click in 2010. And there's our data. This is the phytoplankton abundance. You can see in the legend in the top right here, that the darker the color, the higher the abundance of phytoplankton. So this is all species found. And instantly we can see, the Tasman Sea here between Hobart and New Zealand, there was a hell of a lot of abundance here at that time of year. What you can do is you can zoom right in on these points, and you can add different bits and bobs to them. So you could click on this and it'll tell you what species were found, the day, the year, the month that it was sampled. So very powerful if you want to compare data sets. And then we've got our 2010 there. And let's say we want to compare it to 2011. So you just click in your 2011 and there's all the sampling from 2011. Again, the darker the yellow, the higher the abundance. So for this year, you can see that it's actually a fairly consistent year. There wasn't any part of the Southern Ocean that was any more abundant than any other part. So, you can start to speculate what that means for the ecology of the Southern Ocean at that year. I would point out that that area in the green where the highest abundance was is where the East Australian current comes down from the Sydney area down to Tasmania and New Zealand. And then finally, you can throw in the 2021 data. And you can see here this strong red down towards the Antarctic continent. You can throw in some frontal lines here, look at some Southern Ocean fronts, which, distinctions in the water masses as you cross the Southern Ocean. And the southern boundary of the Antarctic front actually lies where this high abundance is. So you can start to make sort of assumptions, or you can start to make collate your thoughts on what might be happening across the years. These are just 3 years that I threw up as an example, but you can put in any data you want. With the Antarctic krill is managed by an organization called CAMLR, the fishing of the Antarctic krill. And with this kind of mapping in the CPR data set, you can map where the different stages of krill are, where you're finding the adults, where you're finding the juveniles, what time of year you're finding them there. That's really important information for CAMLR. Switch back. So current outputs that the Continuous Plankton Recorder uses, or the Southern Ocean CPR uses. So currently myself and my manager are working on a bioregionalization workshop through CAMLR. So for those that don't know, CAMLR is the Commission for the Conservation of Antarctic Marine Living Resources. Antarctic krill fisheries are managed through them. Patagonian toothfish fisheries are managed through them. So basically, if you're a fisheries operator in the Southern Ocean close to Antarctica, everything is through them. It's kind of like the UN for that area of the world. And there's an annual meeting where states from all over the world come and meet and argue over catch limits. So with this CPR data set and this bioregionalization workshop, CAMLR is currently looking to install a new marine protected area, MPA, on the high seas close to the Antarctic continent. So our data and our work is going into that workshop to try and determine, which areas are important for zooplankton and phytoplankton across the Southern Ocean. SOOSmap. So SOOS is the Southern Ocean Observing System. They have their own mapping program that our data feeds into. This one is a really great tool, the Biological Ocean Observer. This is produced by CSIRO down here. And this is basically takes all the data from the CPR and you can interrogate it in a very user-friendly way. So you can choose your species, choose your map, and choose your abundance or biomass, whatever you want, and it'll map it for you. It's quite powerful. And then our output also goes into a couple of different organizations. So the Global Alliance of Continuous Plankton Recorder Surveys, or GACS, they kind of manage the overall consistently of all these surveys across the world. The Scientific Committee on Antarctic Research, or SCAR, and then within SCAR, you have the krill expert group, and they again feed back into CAMLR, which deal with the catch limits for Antarctic krill. So I guess in summary, this program that we run, the Southern Ocean CPR program and the AusCPR programs, it's incredibly powerful for a very passive instrument and a very resource low instrument. Once you have the instrument, once you have the silks, it can be thrown behind a vessel as it's moving. You don't have to stop vessel. It doesn't take vessel time and doesn't take personnel. The people on board the vessel that are running operations can run it, and they often do. You don't need specific technicians on board to do that. And when you have the process, when you have the data processed, it's incredibly powerful to be able to, I mean, the options are limitless. I've just shown a couple of options on how you can map different things. And when I met Sarah in Japan, I was mapping different Chaetosaurus species in the Southern Ocean against each other. So if you can think of it, you can probably do it with this data set. And it just goes to show the importance of a long-term monitoring program in an open space like the Southern Ocean. The Southern Ocean is warming at a higher rate than other seas due to climate change. So these indicators, these species that can produce quickly and reproduce quickly and bloom and bust, are really good indicators for change in the Southern Ocean. And if we can continue to monitor them, continue to fund these programs, then the data set only becomes richer and the options become more apparent. So thank you. Thank you for listening. Very happy to have a discussion and chat, and yeah, thanks for your time.
Hey, Luke, thanks a ton, especially hanging in there through the power outage and doing this over your phone and your laptop. Really, really appreciate you being creative and making this work.
Thanks.
Super fascinating tools, and I work on studying phytoplankton and the North American Great Lakes, so I have a ton of questions for you. I am just curious right off the bat, when you guys do these tows, do you ever look at the deep chlorophyll maximum? Do you only look in the top of the water column? And I guess a part two, I know it's dangerous to hang stuff off the back of a boat, but could you ever deploy two at one time?
Great questions, David. Thank you. Yeah, a limitation is that's a good point. A limitation in CPR is that it is currently towed at 10 meters deep as a kind of consistent standard. And I imagine you could tow it deeper to reach the sort of deep chlorophyll maximum at sort of 25, 30, 40 meters, whatever it might be. I think you just have to make the stipulation that the data is not comparable to the previous data, which, you know, has its own issues, but I'm with you. I think if you can possibly tow a second CPR, have the one doing the continuous monitoring that's consistent with the data set, and then have a second one that's just doing the deep chlorophyll maximum, that would be great. I will say that because the Australian Antarctic Division is a government organization, it's sometimes hard to implement those changes, like putting two CPRs behind. It's probably a mountain of paperwork for the risk assessment of that. And, you know, if they knock into each other, what happens then? Things like that. But it's definitely been flagged, especially if you do a side tow. If you tow from the side of the vessel and you have the capacity to do it on both, then yeah, definitely. And I think sometimes you can get some ground truthing. You might be able to do like a CPR or a net tow to kind of ground truth the zooplankton there at the time as well. But for the most part, it is that consistent 10 meters. Yeah.
Cool. And yes, as Sarah mentioned, please, if anybody else has any questions, type them in the chat, raise your hand and ask Luke directly. Don't let me ask all the questions because I can. All right, Sarah, go ahead.
Okay, David. Thanks so much, Luke. I really appreciate your talk, and it looks like the lights came on for you.
Yes, thank you. Very exciting.
I was just curious about, just towing a plankton net. You get sort of a water building up in front, and not all the water that you pull through actually goes through the net. So
Yeah.
how do you account for that? Or is there any special little shape of the device that it restricts the amount of water that comes through?
Yeah, that there is a restriction. I'll go back to the image. Yeah, as you can see, this entrance aperture is the only way the water flows through. And from memory, it's about maybe an inch squared. So you are restricting yourself. You know, I've seen some Antarctic krill that are 4.5, 5 centimeters or 2 inches. So if you get one of those krill, a swarm of big Antarctic krill, they're not fitting through this aperture. And if they are at that speed, they're unrecognizable when you see them on the silk later in the lab. So you are restricted by the size of the aperture. I would say for phytoplankton, that's not an issue, obviously. But for the zooplankton analysis, it is. So I guess these CPR records are great. I think the thing that's good is that it is consistent. So if you do find something in the CPR that was there 30 years ago, it's been consistently counted as that. I guess a caveat is that you do miss a lot and you don't really know what you're missing. And that's where you can do your other tows and other ground truthing, but that's resource heavy, especially with a vessel traveling to the continent to resupply. So it's kind of grain of salt for a few things. Another caveat is it can't be towed through the ice. It destroys the instrument. So we can only get records as close as, you're missing possibly those those ice algae that are melting out of the ice in spring and having those blooms. So it's not a perfect system, but yeah, you're right that there are probably a lot of things that are being missed as it comes through the water column.
Yeah, I wonder though if that's part of the design, the small aperture,
Drawing
the
it in.
needle, yeah, the needle-like shape and the small aperture
Yeah, this.
restricts the amount of water coming through. Probably
Well,
some,
yeah, it's hard to see in this schematic here, but this is
yeah,
kind of like a square-based pyramid at the front. So whether that helps too.
yeah. I also, since I saw you in Japan, I learned more about the CAMLR process and looking at Antarctic fishing, the Antarctic toothfish and krill, and just how much fishing goes on. And um, so much of that is on East Antarctica. Are there any of these devices on the other?
Yeah, where's that? I've got that
No,
map.
I guess you are working on East Antarctica.
Yeah, we are. I
You
mean,
are in East Antarctica.
but we're heavily sort of the Indian sector of the Southern Ocean. It is East Antarctica
Oh,
here.
yeah, but in the Ross Sea, it looks like you have less coverage there.
Yeah, and that's more, you know, New Zealand does a lot of that too, because they can just go straight down there, which is great for them. But the coverage is something that's actually being talked about at the moment. There's Dr. So Kawaguchi, who's our resident krill expert, the Antarctic Division, is really pushing for these other states to run the CPR more consistently. So South Africa and South America. I mean, they've got the West Antarctic Peninsula here, and I know a lot of American vessels, US vessels head in this direction. A lot of tourist vessels head in this direction. So there's a real capacity to sample this West Antarctic Peninsula and these subantarctic islands in this area here that's underutilized. I guess Australia seems, you can see from this map, a bit of a leader for the Southern Ocean. But I suppose because we have 3 stations very far away from Hobart, we try to utilize the time and space. Whereas if you've got research or tourism vessels heading to Western Antarctic Peninsula every other day or week or whatever, then it's the time isn't as precious. So we're trying and really push these other states to do more sampling in that area and try and close the gap. I don't think you're ever going to get consistent sampling in this open area here. It's just too far away, too costly.
Have these data been used for the krill populations for CAMLR, for that organization? Is that part of where
Yeah,
they
just
know the
yes, they
impact of harvesting of krill on the population?
yeah, they're used for or they're used for like a proxy for biomass estimates, or at least krill swarm locations. They're not, as far as I know, they're not used as like a post biomass estimate. They're more of a estimate for the next year as opposed to, how's it going from last year. Just the other day, so Kawaguchi asked if I can map, as I mentioned, the distribution of juvenile krill to adult krill across the Southern Ocean, so we can kind of get an idea of where they're recruiting from and where they end up. I'd say it's, yeah, again, used as more of a proxy. You've got your fancy modelers that do a lot of the heavy lifting when it comes to the biomass estimates of the krill, but this is kind of like a second point of contact for that.
Thanks.
There's a couple of questions from Anna and Layla. Maybe Anna, this will be the quicker one. Do you often get something big enough to get stuck and block the rest of the sampling? I know you mentioned getting some larger zooplankton. I don't know, do they ever clog up the sampler?
They don't clog up the entrance aperture, but they can clog up the silk itself. And because it's a slow reeling silk, if you do go through a krill bloom, it is a krill swarm rather, it is just like soup. And the silk comes really bumpy and there's just hundreds of krill. So it's not enough to stop the sampling, or per se, but it does make it hard for me trying to look through the phytoplankton when every field of vision I look at is blocked by an Antarctic krill or multiple Antarctic krill. I do my best to move them without, ruining it for my colleague, but it can become difficult. I'm always very happy to see a krill swarm, though. It's a good thing to see. And then Layla, are all sampling only surface samples? It's possible to evaluate plankton productivity with the column depth of water. I think this kind of tacks on to what David was saying, if you can get parts of like a deep chlorophyll maximum. Currently, it is only the surface sample. It is that consistent 10 meters. And at time, it's probably 7 to 10 meters, just with variability in the water column. But it would be great to do it deeper. It'd be really great to do it deeper. I think, as David mentioned, having a second CPR, so you're still getting that consistent data set for the top 10, and then a second one to go deeper would be good. It just becomes difficult with they're towed 100+ meters behind a vessel, and there's all sort of complications that come with that if you're avoiding a storm and you're turning the boat and things like that. But ideally, yes, deeper would be great.
Just following up on that, how long are the typical deployments of yeah, how long is each cast, time-wise?
Time-wise, you'd probably, a successful one's probably 12 to 18 hours, I would think.
Oh, wow.
So it goes put in. It's often, you put it in, you finish your shift, and then someone else pulls it out.
Cool.
Yeah, they're covering sort of 400 nautical miles, so it's a decent
Wow.
area.
Yeah, and you were talking about off of you know, you guys got to brush me up on what's East and West Antarctica. That's very foreign to me. But south of South America, there, you mentioned there's a lot of the I don't know, civilian cruises going down there, and I just saw a friend who was on one of these, and it seemed like everybody who was on there and all their activities were I don't know if you want to call it ecotourism, but it just seems like it would be, they were all interested in learning and getting out in the environment. It just seems like a ripe group of folks for some citizen science to do some plankton tows or something.
Yeah, I absolutely agree with you. I've got a colleague of mine that works on a program called Fjord Phyto in the West Antarctic Peninsula. She does citizen science with they just collect sample jars and take it back to the lab. But I mean, around Australia, it's been implemented so well on small vessels like passenger ferries and things like that, that we have the kind of the skeleton that we can show people that it is possible. I think the hard part is that you need a dedicated program to be able to process the plankton when it comes back to the lab, and to purchase the silks, which are a lot more expensive than you'd think for a bit of cloth, and purchase the units. You just need that dedicated state that'll do that. So imagine, one of the countries close to the Western Antarctic Peninsula, if they invested the time and money in a technician and a couple of machines, and they could throw it on the back of any vessel that travels to the Antarctic Peninsula. And the number of tourists is reaching 100,000 this year, so there's a lot of boats going down there. So I'm with you. I think there's a gap here that needs to be addressed.
It looks like again, more follow-up questions. Jason has a question. Have there been any observed trends in oceanic fronts? I know you said there were some zones rich in phytoplankton. Have the fronts been relatively stationary, or is there a southerly migration?
Great question, Jason. The fronts do move. They don't move quickly, but actually in oceanographical terms, it's pretty quick, but they do move. So we have something in the Southern Ocean here known as the Southern Annular Mode, and it is the prevailing winds of this area around the Roaring 40s and further south. So if you have years and years of like a negative southern annular mode, which means you get a consistent wind in one direction, then it does push the fronts north or south depending on the amount of years you have these modes. So I think if you have, I can't remember the exact numbers, but I believe it's if you have positive SAM after positive SAM after positive SAM, the fronts can move 0.25 of a degree either every year or every decade. I can't quite remember, but they do move, and 0.25 of a degree is quite a way. So in some work I did for the conference in Japan that I met Sarah at, I looked at the distribution of different species of Chaetoceros, and it looked like there was a fairly clean distinction between when one species would start, the highest abundance of one species would start and the other would stop. Phytoplankton are really good at following these kind of water masses, whereas zooplankton, because they have the ability to move a lot more and they have more complex life histories, trying to track water masses from zooplankton becomes more difficult. But the zooplankton are certainly affected by these areas of rich productivity, especially in that little section I showed in the map earlier. I found that whenever something is sampled in an area across the two different zones, two different fronts, seems to be a lot happening there. You know, there's a lot of eddies in that area, a lot of upwelling, a lot of nutrients being put into the system. And then, of course, blooms are affected by the snow melt and the ice melt that happens on the Antarctic continent. They are harder to measure with the CPR because, as I said, the CPR can't get too close to the ice. But all these processes are definitely playing a part in the blooms we see. And I imagine with the East Australian current creeping further and further south, we're going to start to see some real consequences of that, including toxic dinoflagellates that are normally on the Great Barrier Reef and further north, making their way down to the Southern Ocean, which is a scary prospect.
Thanks, Luke. I was curious in the logistics of working on non-research vessels. You know, you mentioned implementing the sampling. You have to have a dedicated technician, which makes sense after you explain the processing. Do you get on a vessel and say, hey, I need my own berth to set up a microscope next to my bunk, or do you find some space to be able to set up your microscopes?
Well, I think the beauty of it is that a lot of the processing can happen in the lab after the survey, and it generally does. The technician side of things is it's because it's a mechanical instrument with lots of small moving parts. If something goes wrong, you need to know exactly what's happening inside the machine. So generally, if you engage with a new vessel, there'd be a couple of times when you'd go on the vessel with them and run them through it and train someone up that you know is going to be there a bit longer term, or they can train someone else. And then after one or two of those trips, you can generally trust that they know what they're doing with it now. And the vessels, some of them, you know, they've been towing for the program for 20 plus years. So they've got it, it's part of their operations now. They've got a system for it. But I think the hardest part is engaging those new vessels, approaching them, especially, well, I suppose if they're an organization that wants to improve their public facing kind of views, they'll have us come and they'll happily do something they can put on their website to say we support this, you know, oceanic monitoring program. It's the tourism vessels and the other vessels that, you know, get a bit funny about, with all their insurance and operations, just putting a new instrument on board. So I think that the hardest part is engaging a new vessel, and then after that is having a dedicated person to process it. Otherwise, the samples will just sit in a cupboard somewhere for years and years and years.
And so, yeah, when you guys reach out to another vessel, are they, it kind of sounded like, but they're doing this out of their goodwill, maybe again, the desire to promote their public image, but they're basically volunteering their time though, right, to do this? Is that?
Yeah, that's correct. Yeah, it's a lot of goodwill involved in in especially the Australian CPR project, which is this one in purple here. The green one, as I mentioned, is, happening on the back of the research supply vessels. So that's kind of written into their operations. But these ones around the Australian continent itself, yeah, they're the ones where we're relying a lot on the goodwill of people throwing these things on the back of their vessel. And that's difficult, because if you've got 30 years of data and then one day they decide, or 1 year, they decide not to tow for whatever reason, or their vessel breaks, it's just, you're really at the mercy of that consistency.
Yeah, it's a really especially the time efficiency that you've outlined is really I don't know if lucrative is the right word, but when we sample in the Great Lakes, we have to stop, and we stop at a station for an hour or whatever to collect all of our samples. And the idea that almost any vessel can just keep going underway and collect these samples is really cool. Sarah, go ahead.
Yeah, Luke, are you the only one analyzing these phytoplankton samples? Is this all
This is my baby,
purview?
Sarah.
This is your backyard? Yeah.
Yeah, I hadn't never thought of it that way until a colleague said, he was introducing me to someone, and he said that I'm the only person, what do you say? I'm the only person in Australia looking at plankton phytoplankton in the Southern Ocean. That really hit me. I said, oh God, that's quite quite pressure. Yeah, so the samples from the Southern Ocean CPR program for phytoplankton it's all me. Yeah.
Wow.
So that's my main role. I have some things I do on the side, but that's my sort of the main chunk of my role is to do that.
Yeah, it's huge to look at all those green lines, and
I try not to.
you looked at everything of all those plankton across there. Are they mostly diatoms? How much of the other groups do you
Yeah. Yeah, I'd say 70-30 diatom dinoflagellate.
Mhm.
But you do come across some blooms where it's just, lots of dinoflagellates have bloomed in a specific area. Or there's a species, the Australian Antarctica. It's a really long pinnate diatom that just looks like the game Pick Up Sticks. It kind of looks like that when you look down the microscope. It kind of dominates the silk. So you get that sometimes.
Yeah, really fascinating. I really appreciate your work. Thank you for
Thank you.
keeping an eye on the Southern Ocean.
Someone's got to.
That's right.
Cool, thanks. Does anybody else have any questions for Luke right now? If not, maybe we can let him go back to bed. I think it might be 5 a.m. Thank you for waking up so early to do this.
No, absolute pleasure.